Welcome to the Deep Dive, tailored just for you, the learner. Today we're really digging into something fundamental, entities, the building blocks of systems.
That's right. We're working from a really interesting source you shared, that discussion O4 entity band. It's quite dense, originally in Korean.
Yeah, it seems to go deep into how you actually figure out what an entity is, how you refine that definition.
Exactly. It's very practical, almost philosophical in a way. So our goal here is to, pull out the key steps, the core ideas, and make them clear for you.
Think of it as a shortcut, maybe, to grasping this core system design concept, entity identification. It affects everything, databases, business logic.
How a company even understands its own operations, really.
Okay, so let's jump in. The very first thing the source stresses is asking. Is this thing we're looking at actually a set we intend to manage?
Right. And it sounds basic, but it's not always obvious.
How so?
Well, the source makes a great point about scope. What set are we talking about? The whole system, just one package, a single step in logistics.
So the boundary you draw changes the answer.
Completely. Defining that scope, deciding what's in and what's out is absolutely the first hurdle. You have to know the boundaries of what you're trying to manage.
And it's not just like physical boundaries. The source mentioned time, too.
Yeah, the time horizon. Are we only looking at right now? Or do we need to think about the future? How far out? That's a strategic piece.
Okay, that adds complexity. So if you're unsure about the scope or the future.
Who do you ask? Good question. The source really emphasizes finding people who know, getting informed input to make sure your definition of the set makes sense now and, potentially later.
Right. Okay, so we've maybe defined a set we want to manage. What's next? The source talks about area needing horizontal and vertical axes.
Yes, area. So for a set to potentially be an entity, it needs these two dimensions. Think of the horizontal axis in the original as the attributes.
Characteristics.
Exactly, the things we want to track about the items in the set. And the key here is there have to be at least two attributes.
Right.
Well, if there's only one attribute you care about, it's maybe just a list, not really something complex enough to need its own entity structure, perhaps. The point is you need some descriptive breadth, more than one characteristic.
Okay, at least two attributes. And the vertical axis. See at the show?
That's the number of instances, the individual items in the set. So if your set is customers, the vertical axis is how many individual customers there are.
And again, there's a minimum.
Yes, same logic.
Yeah.
You need at least two instances. If there's only one customer or one product, it's usually not treated as an entity set in this modeling context. You need a collection.
So to have area, you need at least two attributes you care about and at least two individual instances that have those attributes.
Precisely. That's the essence of the area check. The source calls it a 100-point check, maybe meaning like a fundamental pass-fail test.
Like a quick sanity check. Can we find two characteristics and two examples? If yes, okay, maybe we have something. If no,
then it might not be a true entity for the system you're modeling. At least not yet, or not defined this way.
got it. But the source warns us just having area doesn't automatically make it an entity. The analogy was all squares are rectangles, but not all rectangles are squares.
Exactly. Being a set with area is necessary, but not sufficient. There are other conditions. The source lays out three big ones: independence, homogeneity, and purity of essence.
Okay, let's break those down. Independence first.
This means the set has to stand on its own. It shouldn't be completely contained within another entity set you've already defined.
Like the example, if customer already includes individuals and corporations, defining corporations separately isn't independent.
Right, because it's already covered.
Right.
But defining individual might be independent from corporation. It's about avoiding redundancy and keeping the definitions clear. Makes sense, right?
Yeah, absolutely. Prevents confusion.
Okay, next, homogeneity.
John?
Homogeneity means the things inside the set need to share a common nature based on how you define the set.
So if the set is full-time employees,
Then part-timers wouldn't belong because they don't share that full-time characteristic. But if you defined a broader set, like all company employees, then they would all fit. The definition dictates the shared nature.
okay, clear boundaries based on the definition. And the last one sounds important. Purity of essence.
This one gets to the core of what the entity represents. The idea is an entity set should be based on either its inherent characteristics, what it is, or its behavioral characteristics, what it does, but not a mix of both within the same core definition.
Can you give an example?
Sure. Payment is an action, a behavior. LG Electronics is an entity, a thing. A set containing both wouldn't be pure. You wouldn't typically model payment and company as the same kind of entity.
Even if the word sounds like an entity.
Yeah.
The source mentioned a Korean suffix stone often indicates an actor.
Right, but you can't just rely on the word. You have to look underneath. Is it fundamentally a thing, a concept, or an action? That determines its essence.
Okay, that's a critical distinction. Let's circle back to those axes for a second. The horizontal attributes. Should we only list attributes we manage right now?
Good question. The source advises thinking a bit broader. You need at least 2 attributes now, or that you anticipate managing soon. Considering the future makes your entity definition more robust.
So you don't need the full list up front, but thinking ahead helps define the scope better.
Exactly. It helps future-proof the model a bit.
And the vertical axis, instances.
Yeah.
The source mentioned subsets like potential customers within customer. How does that affect defining the main entity?
The key is defining the core entity at a level where you can still uniquely identify individual instances based on the shared attributes. Subsets might exist for specific purposes, but the main entity definition needs that core identifiability.
The whole idea of management seems really central to this whole process.
It absolutely is. It's not just identifying stuff, it's identifying stuff we intend to manage. And that includes both what we manage now and strategically what we should manage for the future.
So modeling isn't just describing, it's informing strategy.
Yes, definitely. It should help with analysis, decisions, improvements. Proactively identifying future needs is a big part of that.
I can imagine sometimes people focused on the day-to-day might resist adding structure for future needs they don't see yet.
Oh, sure, the source acknowledges that, but it argues it's the modeler's job to see that bigger picture and articulate the benefits. To say, look, structuring it this way now will help us here and here down the line.
Okay, let's shift gears a bit. The semantic primary key. That sounds interesting. It's not the database ID, right?
No, not at all. System IDs, record numbers, those are what the source calls artificial keys. Useful, but not the real identity.
So the semantic key is?
It's the true inherent identity, the real-world factors that make that instance, that specific instance. The source uses a great analogy. It's like the parents that led to its existence.
The Hong-Gil-Dong example. His ID is artificial. His parentage is semantic. It's the real-world origin.
Exactly. It's the why this one exists uniquely. And there's a practical test suggested. If changing an attribute forces you to create a whole new record, that attribute is probably part of the semantic key.
Because it changes its fundamental identity in the context of the system.
Right. But if changing an attribute just updates the existing record, it's likely just a descriptive characteristic, not part of that core semantic identity.
And using sample data helps see this, making concrete examples.
Immensely. Laying out example records with different combinations of attributes makes it much clearer which ones are truly defining the uniqueness. It bridges that gap between abstract rules and concrete reality, especially when talking to people who aren't deep into modeling theory.
Makes sense. The source then uses a case study. Subscribers versus payers. Why aren't they always good entities on their own?
Well, they might look like sets with area, right? Attributes, multiple instances.
Yeah, seems plausible.
But they often fail the other tests, independence. A subscriber might not be the payer, a payer might not be the subscriber. They overlap but aren't necessarily the same set.
Okay, so not independent.
And homogeneity can be tricky too. But the bigger issue is often purity of essence. Payment is an action. Subscriber refers more to a state or role of a person or company.
So mixing action and entity state.
Trying to make one single entity out of both violates that purity principle. The real entities might be the person, the company, and the relationship or role they play as a subscriber or payer. The act of payment or subscribing describes that relationship.
Ah, so the action is more of a link or an event, not the core thing itself.
Often, yes. The distinct, unified sets are the things playing those roles.
Let's revisit homogeneity. It sounds like getting that right involves some judgment calls. The fraction analogy came up again.
Yeah, it's about finding the right common denominator. How do you group things together based on shared characteristics without losing what makes them distinct?
Like grouping fractions by multiples of 2 or multiples of 6, or finding one denominator for everything.
Exactly. How you group them defines the homogeneity. You can group different entities if they share some attribute or purpose.
But there's a trade-off between integrating things broadly and keeping their specific meaning.
For sure. Integrate too broadly and you might lose essential distinctions. The source used a metaphor like mixing water and ink. You get a mixture where neither is pure anymore.
So the goal is to integrate enough for common management, but not so much that you lose the crucial differences.
Precisely. Maximize integration without losing essential meaning. How do you contain the ink within the water without just diluting it? Maybe by using a separate container, like a type attribute, to keep identities clear within the larger set.
That allows flexibility later on. Okay, what about overlap between potential entities? The example was customers and administrative agencies like tax offices.
Right. A specific tax office might be a customer of a bank, but not all administrative agencies are. So you have this overlap.
How do you handle that?
Two main ways discussed. One, broaden the customer definition to just include all administrative agencies. Covers everything, but
But then your customer set might become huge and unwieldy if you're looking for specific types, like finding a small drone in the ocean, as the source put it.
exactly. The other way is to filter or refine, create more distinct categories. Maybe individual customers, corporate customers, government agency customers.
And the choice between expanding or filtering.
That's critical. It depends entirely on the context, future needs, how you need to search and report. It's rarely a simple yes-no. It's a key modeling decision.
This all points towards the importance of simplification, doesn't it? The source had that great line, upper water must be clear for the lower water to be clear.
Absolutely. If your foundational entities, the upper water, are complex and messy, everything built on them, the lower water will inherit that mess.
So the goal is to simplify and unify those core high-level entities.
Yes. Find the common denominators, unify similar concepts, like the example of rolling up bank partners, suppliers, cooperating firms into one broader business partner entity.
What's the payoff for that simplification?
Less redundancy, clearer relationships, a system that's much easier to adapt later. Even if different partners have unique relationships, the overall structure is cleaner. Complexity breeds complexity.
Okay, so far this sounds mostly like a top-down approach. Start with concepts, define entities, build down.
That's been the main focus, yeah, defining things from the top.
But the source also brings up a bottom-up approach. Reverse modeling. When is that useful?
Hugely useful, especially when you're dealing with an existing system, maybe one that's grown organically or isn't well documented.
So instead of designing the ideal structure, you look at what's actually there.
Exactly. You look at the born children, the entities and data that already exist, and you work backward. You try to identify their parents, what higher level entities and relationships must exist to explain the data you see.
And if you can't trace an existing entity back logically,
That tells you something's missing or wrong in your understanding of the higher level structure. Maybe an entity wasn't defined or a relationship was misunderstood. It's a powerful way to diagnose and refactor existing systems.
and the key in this bottom-up view is finding the semantic subject again.
Yes, finding the real driver for why that existing entity record is there. Again, ignore the artificial keys, the stage names, and find the real identity.
How do you find that looking bottom-up? The source mentioned dependencies.
Right. Look for absolute dependencies, things the entity absolutely needs to exist, and direct dependency is a one-step relationship. Those point you towards the likely parents, the semantic subject.
And the 6 W's come back here too. Who, what, when, where, how, why.
Definitely. For any existing piece of data, ask who did something, what was involved, when did it happen, where, why, how. The who and what are often your primary semantic subjects. The when is usually a key trigger event.
Like the purchase request example again. Looking at an existing request record. Who requested it? What item was requested? When was it requested?
Those answers likely point to the core semantic subjects, the employee, the item, the date that explain the existence of that specific purchase request record. The combination of those tells the story.
If you can't answer those W's,
Then you don't really understand that piece of data or the entity it represents. It's like the source says, adoptees searching for biological parents, that fundamental need to know the origin.
okay, wow. That's a lot to digest. Let's try to wrap this up for you, the learner. This whole deep dive, it shows entity identification is way more than just listing nouns.
It's a really structured way of thinking, isn't it? It forces you to consider scope, relationships, time, the future, the real essence of things.
And here's where I think it gets really interesting for learning in general. Knowing these principles gives you a toolkit, a framework, to analyze almost any complex information.
Yeah, absolutely. You can start asking these deeper questions about the core elements in anything you encounter, business processes, scientific concepts, data sets. What are the fundamental sets? What are their key attributes? How do they relate?
So for your learning journey, hopefully this provides a bit of an aha moment. Seeing the importance of clear definitions, the underlying logic, It's not just abstract theory for programmers.
Not at all. It's a practical skill for making sense of complexity anywhere you find it.
So maybe a challenge for you. Next time you encounter a new system or a chunk of information, try to consciously identify the core entities as we've discussed them.
Yeah, what are the fundamental sets, the key characteristics, the relationships? Just thinking that way can bring a lot of clarity. It's a powerful lens.
And maybe a final provocative thought to leave you with. If the core entities in any system, whether it's software, a business, even a social structure, if those entities are poorly defined or misunderstood, what are the long-term consequences?
Consequences for efficiency, adaptability,
Hmm.
even for just fundamentally understanding what's going on.
Yeah, something worth mulling over.